Hi, in this video, I will be showing you problem number 9 of chapter 7, section 8. Determine whether the integral convergent or divergent. Integral 2 through infinity e to the negative 9p dp. Let's call the given integral as I, as we normally do. Note that one of the limits in this case is infinity. So that means it is an improper integral. In this particular case, as it is 2 through infinity, the interval over which the function, the integrand is given is an infinite interval. So it is improper integral of type 1. So it is improper integral of type 1. So we will write the integral as limit t approaching infinity, integral 2 through t e to the negative 9p dp. So which is limit t approaches infinity, integral of e to the 9p is e to the negative 9p is e to the negative 9p over negative 9 between the limits 2 between the limits 2 and t. So it is negative 1 over 9, which can be pulled out of the limit t approaching infinity. So now you plug in the upper limit, it is e to the negative 9t, and plug in the lower limit, it's minus e to the negative 18, negative 9 times 2. So keep in mind, t is now approaching infinity. So it is e to the negative infinity, that will be a 0. Then we have negative e to the negative 18. This part will approach 0. So negative and negative makes it positive. So it is e to the negative 18 over 9. As this is a specific value, a finite value, so the integrand is convergent. The limit exists and therefore you conclude the integral is convergent. In these problems, especially when you do improper integral problems, it's just not enough if you just say convergent or divergent. You have to prove how you conclude that the integral is convergent or how you conclude the integral is divergent. So arriving at the value of the integral is important in these problems. Hope this video helps.